All right, hello everybody. We're going to do a quick lesson today. It's a fairly simple one, just on some prerequisite skills that are going to come in handy, just to kind of refresh on before we jump into some new calculus stuff later in the week. So the things that we're going to go over today are factoring and all the different kind of types that we might encounter and just kind of review how to do those, as well as rationalizing. So we're going to go over that today. So let's start with factoring. So what is factoring? So that is breaking a polynomial. Sorry, let me get my pen going here. Into pieces. So here are lots of different types of factoring. So the first and probably the easiest is common factoring. So we're just looking for our greatest common factor that we're going to pull out front and then write whatever's left over after we've divided out that greatest common factor from all of our terms. So in this case, we can factor out a 3, which leaves us with an x plus 2. Then the next kind of easiest one would be simple trinomials. So we're trying to think of two numbers that multiply to give us that last term, 12, so positive 12, and add together to give us that middle term of negative 7. So those numbers are going to be negative 3, so we put that in our first bracket here, and negative 4. So that one's fairly simple, not a lot of work to be done. You can just, once you find those two mystery numbers, you just plug them right into the black brackets. With more difficult trinomials, so when we don't have 1 as our leading coefficient, so we've got some other number there. In this example, we've got 2. We have to multiply that 2 to our last number here, so 12. And we're now thinking about 24. So we're thinking, what are two numbers that multiply to give us 24 and add to give us 11? And when we find those two numbers, we're actually just breaking up that middle term of 11 into those two numbers. We're decomposing it. So two numbers that multiply to give us 24 and add to give us 11 would be 8 and 3. So we're going to break that 11x into 8x plus 3x. So we've got 2x squared plus 8x plus 3x plus 12. And now we're just going to take the first couple terms and common factor from those. So we could take a 2x out, which leaves us with an x plus 4. And then over here, we could take a 3 out, which also leaves us with x plus 4. And so now we've got that x plus 4 in both parts there. So we can actually now common factor that out. So if we common factor out an x plus 4, then we're left with 2x plus 3. And now it's in factored form there. Difference of squares is the next one here. So if you notice that you've got a square number at the beginning of an expression and then a square number at the end, and they're separated by a minus sign, then we can use the difference of squares factoring method. So all we do is we square root the first term, square root the second term, and that's what goes into our two brackets. One of the brackets will have a plus and one of the brackets will have a minus. So it'll look like this. So the square root of 9x squared is just 3x. Square root of 25 is just 5, so we have a minus 5 in one, and then almost the same thing, but then a plus 5 in the other. Okay, the next couple are similar to the one above, but now we've got cubic numbers. And actually, I'm just going to point out that I made, let me see if I can highlight this here. On your paper, I believe there is a 2 instead of the exponent of 3. So both of these should have an exponent of 3 because we're dealing with the sum of two cubic numbers. So just fix that on your paper copy. And now to factor it, so here is kind of the setup of how we do that. So once you notice that you've got two cube numbers, we're just going to cube root them, and then at least then we know what our A is and then what our B is, and then we're going to plug them into this kind of formula here. So for example, if we cube root this 27y cubed, we're going to get 3y, right, because that's the same. And then here we're going to have a 2. So those are our kind of our base numbers there. And so if we plug that in to the formula above, so we're going to have our A, right? This is our A and this is our B. So we're going to have 3y plus 2. And then in the next one, it says to do A squared. So that will be 9y squared minus, and then a times b, so 2 times 3y. And then lastly, plus b squared, which is just 4, because 2 squared is 4. And we're going to do almost the same thing down here with difference of cubes, except because there's a minus sign separating our a cubed and our b cubed, we've got a bit of a different formula. But again, to kind of figure out, this is our a term, so just an x, and then this is our b term, is just a 2. And now we plug it in. So we're going to have x minus 2, and then x squared plus 2x, and then plus 4. Okay, now in the next example here, sometimes you're going to get different expressions, and there's going to be multiple types of factoring that you're going to need to apply to get it into that fully factored form. And so the first one you're going to always want to look for is a common factor. So if you can common factor first, do that as your first step, and then kind of see what you're left with, and then go from there on what type of factoring you should be doing next. So we know that we can take a 4 out, which leaves us with x squared minus 25y squared, and now we see that we have a difference of cubes, because within the brackets, that x squared, that's a square number, and then our 25y squared is a square number, so we've got difference of squares. Sorry, I think before I might have said cubes, but I meant to say squares. So we're going to use our difference of squares. So we're going to have x minus 5y in the first bracket, and then x plus 5y in the second bracket. So now we're going to look at more complicated factoring. So you see that it starts with an x cubed here, unlike all the, most of the other ones we looked at just started with an x squared, and we were able to use, decomposition or just simple factoring. This is a little bit different, and so with this, we need to think back to factor theorem. So first, I'm actually just going to let this equal a function. So we'll call it f of x. Okay, so factor theorem tells us that if we can sub in a number for x that makes the whole function equal to 0, then we know that that is a factor. So we're going to try, make a little note on this so you can remember how to do it. So try subbing in different values of x until we get f of x equals 0. So I always start with smaller numbers, right? It's easier to sub in a smaller number. So I start with 1. If that doesn't work, I maybe try -1, and then I go up to 2 and try -2. And hopefully, you don't have to go much higher than, 3 or -3 before you've at least found one of the factors that would bring your whole function to 0. So for today's example, I'm going to start with subbing in a -2 and seeing how that works out for me. So I'm going to have -2 cubed minus 6, and then -2 squared. Okay, so let's see what that equals. So now we've got a -8 minus 24 plus 2, and then plus 30. So that does bring us to 0. So that tells me that x plus 2 is a factor. Right, because if you think about setting this to 0, that's why it's a -2, like when we subbed in x is -2, but when we write it kind of as a bracket here, as a factor, it would be x plus 2 would be our factor. So once we know one of them, that's when we can kind of do long division or synthetic division. So you can choose which one you like best or which one you remember the most. And go from there. For today, I'm going to use synthetic division. So we put, oops, why is this moving around here? So we're going to put the number that we know does make it 0 out here to the left. And then we put all of our coefficients of the function all along the top here. So we've got our first coefficient is 1, and then we've got a -6, then we have a -1, and then we have a positive 30. And so the first step is to just carry down that 1. And then we're taking our 1 and we're timesing by the -2 off to the left there, and that gives us a -2. So we write that down, and then we just add going down. Okay, so -6 plus -2 is -8. And now we do the same process again. So -8 times this -2 over here. I'm just going to erase that. I just wanted to kind of point to it so you guys know where I'm looking. And that gives us a positive 16. And we add going down, which gives me 15. And then finally, 15 times -2 is -30. And that gives us a 0. So it should always have a 0 there for our last one. And that's how you know you've chosen the right factor and that it's right. So these are now the coefficients of our next function that's going to be inside, or part of the expression, I should say. So we know that this, right, this is the factor x plus 2, and then we're left with, so these are the coefficients. So 1 I don't need to write, but now it's x squared, and then we've got minus 8x, and then this 15 is going to be our constant. So this is what we're left with. Beside that first factor. And now from here, we can just, it's a simple trinomial. So now we can just do simple trinomial factoring. So what are two numbers that multiply to give us that positive 15, but add to give us a -8? So that is going to be x minus 3 and x minus 5. And so now it is in a fully factored form.